The Moscow State Circus acrobats are world famous for their daring acrobatic skills. In their speciality act, one acrobat stands at one end of a springboard, while another prepares to drop from a height onto the opposite end. When the jumper hits the board, the harnessed acrobat is catapulted into the air. It relies entirely on a simple lever. The pivot is at the centre of the springboard, the point about which the lever turns. The load is the acrobat standing on the board. The effort force is provided by the acrobat jumping from a height. As the effort force pushes down on one end, the load is lifted at the opposite end. As with all levers, there's a turning effect. The effort force landing on the left-hand side of the springboard produces an anti-clockwise turning motion. So, what happens when the effort force is increased from one jumper to two? Increasing the effort force increases the height gained by the acrobat. The turning effect of the lever has increased. You can calculate this turning effect by multiplying the size of the force by its distance from the pivot. The turning effect is equal to the force times the distance. Let's go back to just one acrobat. He weighs 100 kilograms, which means he lands with a force of 1,000 newtons, at a distance of 1 metre from the pivot. The turning effect is 1,000 newtons times 1 metre, which is 1,000 newton meters. So, what about two acrobats? Their combined weight means they land with a force of 1,500 newtons. This time, the turning effect is 1,500 newtons times 1 metre, which is 1,500 newton meters. If the pivot was moved further to the right, the force would be acting over a greater distance. How would this change the size of the turning effect?